So again, still kind of the same idea. The stock market, kind of we're talking about things, fluctuate. Number one rule of stock marketing is buy low, sell high, right? Yeah. If you knew when those high points are and low points occurred, we could be well on our way to track and making a fortune. We're going to look at some functions and be able to figure out what are some critical points so that we can see what those values would be at certain days in this example. So we've got a value of a stock that is T days into February, given by this function, for 0 to 28. Okay? So T is number of days into February. So T being 1, right, would be February 1st. Okay? So if we are wanting to find critical points of this function, critical points are when my derivative is equal to 0 or it is undefined. Okay? Looking at this function right here, I have a polynomial. Is a polynomial ever going to be undefined? No, it is always going to be defined. It's always going to be continuous. So we can just go ahead and we're going to take the derivative of this function and set it equal to 0. Okay? So s prime of t, I'm going to leave the 0.2. I'm not going to distribute it just because then it'll make taking the derivative just a little bit nasty with your fractions and things. So I'm going to leave it on the outside, and we can do that because it's just a constant that you're multiplying in. So we can take the derivative of everything in the parentheses there, which will be easier to factor for us. Okay, so derivative of 2/3 x to the third would be 2x squared minus 41x plus 90. Okay, now I want to know when does this equal 0. That is when my critical points, or that's how I find my critical points. Now I could sit here, I could solve this by hand. I could also plug this in my calculator and do polyroot finder. Do you remember how to do that?
No.
On your calculator, go to apps, go to polysmelt 2, and you are going to plug in only this function, 2x squared minus 41x plus 90, and it's going to give you what x equals. Well, if we think about it, I could divide by 0.2 on both sides, and it would still be 0. So I don't really need to worry about the 0.2 unless it had an x with it, okay? So plug that in your calculator and see what is your x values going to equal. You should have 2 of them.
Wait. How do I do this?
Yeah, you should get 18 and 2.5. Okay, so that is my answer. Those are my critical points on this function. Okay, so what does that mean? That means that at these 2 points, they're either going to be relative minimums or they're going to be relative maximums. Or maybe they're the absolute minimums or the absolute maximums. Okay, that's what we're going to figure out here in a second. Next question says, at what t value does the stock value have a relative maximum and how do you know? So I need to kind of test some points. If I look at, we've done this one other time here, look at a chart, okay? This is my s prime of t. And the 2 points that I'm going to look at, or the 3 intervals that I'm actually going to look at, are on either side of those 2 critical points. So if I look at the left-hand side here, if I pick a point to the left of 5/2, if I pick 0, for example, okay, when I plug 0 in back to my derivative function, am I going to get a positive or a negative value for x? If I plug in 0 here. Positive, okay? I'm just going to put a little plus sign up there. All I care about is just knowing what the sign is. Okay, let's pick a number in between 5/2 and 18. 10, okay? Pick 10. If I plug 10 in, all I care about, is it going to be positive or negative?
Positive. Negative.
It is actually going to be negative, yes. So it is a negative, and then if I pick a point to the right of 18,
Positive.
let's say 20, and it is actually going to be, wait, positive or negative?
Maybe. I think 20 squared is like 400.
20 squared minus 41 times 20. Plug that in your calculator. I do believe it should give you a positive.
This is what we did in pre-calc.
Yeah.
How interesting.
We've got our slopes are changing from positive to negative, negative to positive, okay? So if we think about this, my relative maximum, where's my relative maximum occurring?
After 18. Or at 18. Wait, no. That's not that. I don't know.
If it's positive and then it changes to negative, our maximum is happening at this point right here, because I'm changing from a positive value to a negative value.
So
Okay, so I'm changing from I was trying to draw a little line here. I'm changing from a positive value to a negative value. So that's my maximum point there. Okay, so at x equals, or t equals 5 halves, that is our relative maximum because we change from positive to negative. Before we answer the second part of that question, I want to talk about what is the relative minimum. Looking at that same sign chart up above, my relative minimum would be changing from your negative to your positive. So it would be at 0.18. Okay, so at t equals, or x equals, yeah, I should have probably put t up here because that's what our function is defined as, but that's okay. At t equals 18, we have a relative minimum because we change from negative to positive. And it very well might be, but we have to check 2 other points that we'll talk about here in a second. Okay? So these other 2 kind of part 2s of these questions are asking us, what is the stock value at that specific instant? So if I wanted to know what is the actual money value of the stock at the day 2.5 after February has started, what function would I plug that back into? S of t, right? So I want to figure out, what does S of 5 halves equal? I know you guys all can use a calculator, so I'm going to help us out here, save us a few minutes. 251.46 approximately is what you should get for that value. And now I want to also find out, what is the stock value at t equals 18. So plug in 18 as well. So S of 18 would give me $3.20. So 18 days into February, the stock is at $3.20. 2.5 days into February, the stock is at $251.46. But kind of what that question that you were just asking about is, what is the absolute highest attained and the absolute lowest attained in the month of February? How do we know? Well, we know that there's those relative points that we can check by the critical points, but we also need to check, because like on that previous note page, remember, like the highest point was actually at the beginning, right? And at the end, it was not the highest or lowest point, but it still was like a relative maximum, right? So I still need to test the beginning and end point to see if either of those points are higher or lower than either of those 2 points that we just got, okay? So I need to test S of 0, because it's the first day, right, or the beginning of the month, and S of 28. So if I plug both of those in the calculator, again, I know you guys can use your calculator, you should get 230 and 446.53. So let's think about that. Is this relative maximum my absolute maximum?
No.
Looking at these 4 points. No. My relative maximum, or sorry, not relative, my absolute maximum is at the point 28, comma 446.53. Okay? So that is my absolute maximum. So the highest value during February occurred on the last day. Okay, so then absolute lowest value obtained during the month of February. Obviously, we've already got the endpoint values here, and then we have our critical point of 18. So what is our lowest value? The $3.20. Okay, so our relative minimum is also our absolute minimum. Okay, so absolute minimum is at day 18 into February. I could have just said February 18th, but I said that. At a value of $3.20. Okay, so on this next page, we're going to talk about candidate testing. We just did candidate testing. You just didn't know what it was. But candidate testing is testing the critical points and the endpoints to see where is our relative or our absolute minimum or maximum. Okay, so for these last two questions, we actually did candidate testing. So I'm going to show you what candidates we tested. We tested the candidates of t equals 0 and 28, which are our endpoints. And we also tested the point 5/2 and the point 18. Okay, testing all of those points and plugging it back into our original function s of t allows us to find out what is the largest or the smallest value on our graph. Okay, so we're going to make some t-charts, okay, after we found the derivative, after we found our critical points to figure out where we have relative minimums, relative maximums on the next page. Yeah, t-charts. So we are finding absolute. Sometimes you'll also be, it'll be called global in some textbooks and some questions. So if you see global or absolute, it means the same thing. Maximum and minimum. That's what we are doing. First step is we need to find and list all the critical points and endpoints. So that means that we have to set the derivative equal to 0 and solve to find my critical points. The endpoints just come obviously from our interval. Okay, next thing that we're going to do is we are going to compare all of those values on the function at the specific x values. I should probably say compare the y values there of the function at the specific x values. So this is where we're going to make our table or make our t-chart, where we have our x values on the left and our f of x values on the right. Okay, or you have your critical points. Sometimes you'll see critical points abbreviated with CP, and then your endpoints as well go over there. And then lastly is we need to write a conclusion of what are we finding, what is the question asking us, did we find a relative or absolute minimum or maximum. And in our conclusion, I want us to say something along the lines of f of x has an absolute max or min of whatever value at x equals something. So on that previous example, it would be something like, you know, the stock value has an absolute minimum of $3.20 at x equals 18 or t equals 18. Okay, that just kind of answers the question in general. So we're going to look at number 1 and number 3 down below, and then I'll let you guys get working on your homework, or at least get started on it. Okay. Okay, number 1 says, at what x value does this function have an absolute maximum on the closed interval from -2 to 4? Okay, so first thing that we got to do is we got to figure out what are my critical points. So I got to take the derivative. Take the derivative of this function, and I get
3x squared minus 6x.
3x squared minus 6x. Okay? Well, I want to know when this equals 0. That's what I actually care about. So you can either plug that in your calculator, or this one's a pretty quick and easy one that we could factor to get 3x times x minus 2, which means my two numbers would be 0 and 2 for this case. So now I'm going to make a table. I've got my x values, and I've got my f of x values. My critical points are going to go on there of 0 and 2. But then I also need to include my endpoints of -2 and 4 to see, are those two values bigger or smaller? And we care about right now what's the biggest of all of these f of x values. Okay, so now all we do is we take this value of -2, plug it in anytime you see x in your regular f of x function. And again, I know you guys can plug these in the calculator. I'm just going to give them to you. We get -8, 12, 8, and 28. And I got all of those values just by plugging it back in to the original f of x function. So now looking at this table, I can see my relative, or not my relative, but my absolute maximum for this function would be at the point what? 28. Okay, so we can say something along the lines of f of x has an absolute maximum of 28 at x equals 4. One other way actually to make it even better is we can say by the candidate's test. If it says to like justify, that would technically be your reasoning. The candidate's test is what allows us to do this, and the reasoning behind why it works. Okay? Unfortunately, sometimes they aren't always this easy. Sometimes the derivative is a little bit trickier. Okay, so that's why I want to do number 3 with you as well. The derivative's a little bit messier on this one, just to give you another kind of example before you get going on your homework. So let's look down here at number 3. I've got the position of a particle is given by x of t is equal to e to the -t sine of t for the interval 0 to 2 pi. Okay, find the time at which the particle is farthest to the left. So farthest to the left, we got to kind of recall, what does that mean in terms of my derivative? Do I want the derivative to be the largest, or do I want the derivative to be the smallest or the most negative? It is the most negative. That's exactly right. So we want to find when our derivative is less than 0, and specifically when it is farthest to the left or the most negative. So we're finding the absolute minimum. But to start us out, we got to take the derivative. So the derivative of this one, we are going to have to use product rule and chain rule. Okay. So why don't I give you guys a minute to try to write this derivative out yourself before I go ahead and show you what it should be. So now that I've got my derivative, I need to set this equal to 0. Okay. What could I take out of both of those factors? An e to the -t. Let's do that. Take out an e to the -t, and I'm left with cosine of t and sine of t. Oh, actually minus sine of t, because of that negative from the chain rule. Okay. Now, if this was just like an x squared outside, I'd set x squared equal to 0, and I would set this equal to 0, right? Well, if I set this equal to 0, is there any number that I could take e to the power of to get 0? No. Okay, so I can't set this equal to 0. It's not going to give me an answer. So I do need to set this answer in parentheses equal to 0 and solve for that. So when does cosine of t minus sine of t equal 0? Or when is cosine of t equal to sine of t? What value of t on the interval 0 to 2 pi?
Pi over 4.
Pi over 4 and?
Negative pi over 4.
Not negative pi over 4, because I want the interval to be 0 to 2 pi.
3 pi over 4. 7 pi over 4. Wait, yeah. 5 pi over 4.
5 pi over 4.
Let's
Yes.
Go, Daniel.
But yes, so t is equal to both pi over 4 and 5 pi over 4. Okay? So, now that I've got my critical points, I can set up my table. So my table is going to have x values and it's going to have f of x values. I will have both pi over 4 and 5 pi over 4 on this table. But I will also have my endpoints. My endpoints are from that interval at the beginning of 0 and 2 pi. It just so happens that we've been getting only 4 answers. It's not always going to be 4 answers. You might have less, you might have more, okay, depending on how many critical points you have. But each one that we've done so far has only given us 2 critical points and we have 2 endpoints. So from here, I go ahead and plug in these values to this function, x of t. And again, I know you guys can use a calculator, so I'm just going to tell you what you should get. 0, 0.322, negative 0.0139, and 0. Okay, those are all of my f of x values that I get when I plug it back into my function. So my absolute minimum occurs at what x value? 5 pi over 4. So my absolute minimum, I could say something like f of x, or actually x of t is what the function is, isn't it? X of t has an absolute minimum of negative 0.0139 at x equals, or actually t equals in this case, isn't it? Technically, t equals 5 pi over 4 because, or by, the candidate's test. Okay, so your homework is on Schoology. There are, I think, about 9 problems similar to this that you will try out. If you have questions on those, we'll go over those next time. And then please make sure you also get onto AP Classroom and watch that video. There's 2 of them, I believe. And then there are 6 multiple choice questions. This is also on Schoology. It will be a completion grade, so you will get a grade for it. So please do it, okay? And if you got questions on those multiple choice after you see the answer,